refuse to not give you your money's worth. Partially because if you guys don't know anything about organic chemistry, you might kill me one day while you're going into medical school and stuff. And a lot of you will stay around this area. Nashville's considered a pretty nice town. Nashville area. Yeah. Okay, so the basic idea of Vesper theory. So we're going to be talking about three-dimensional geometry, intermolecular interactions, and physical properties. This is going to sort of build you up. Once you understand things like Vesper, you're going to realize that realistically speaking, organic structures just copy and paste 20 times and maybe wrapped around. Like, there actually is very little information you actually need. You can figure out from base. Now, the basic idea of Vesper theory is that valence electrons around an atom are going to be treated as, this book calls it electron groups. Different books actually call it different names. I actually prefer electron domains. So you might catch me saying electron domain instead of electron group. Because electron domain actually says what it is better. It's a space those electrons occupy. Okay? But either way works. Lone pairs, these have two electrons, and that is one electron group or domain. A single bond has two pairs of electrons, and that is, again, one domain or group of electrons, because they're going to move in the same area, right? They can't split up. You can't have your double bond over here, single bond over here. It's not a double bond anymore, is it? Single bond has two, again, one domain. Double bond, 4, one domain. Triple bond, 6 electrons, still one domain, right? Because the triple bond's all one area. Okay, so the electrons in a Lewis structure is going to be viewed as groups whenever you write your Lewis structure. The negatively charged, excuse me, electron groups are going to strongly repel one another. So these different domains are going to try to spread out as much as possible because they repel each other, right? So what would happen if you guys were really stinky to each other? You'd spread out as much as possible, right? Yeah. You would repel each other, right? Oh, yowza. And so they tend to arrange themselves as far away as possible. You can actually kind of do this yourself if you want by taking some balloons and tying them in one stem around the middle. Okay? And they'll actually make, depending on how many groups you add, the different Vesper geometries. Okay? So electron geometry is going to describe the orientation of the electron groups or domains around a particular atom. And so it's the geometry of electrons only, right? We don't care if they have atoms at the end, whatever the electrons are, okay? Molecular geometry, this is going to describe the arrangement of the atoms around a particular atom, okay? So it'll be the electron geometry around the carbon in the middle, okay? The electron geometry around this specific atom, okay? And again, this is going to be molecular geometry, the atoms. So if you have like a lone pair, that doesn't have an atom on the other side, does it? So it's going to be ignored for molecular geometry. It'll just take up space. It isn't actually part of the geometry, okay? Okay. So here's some different examples. These ones just have straight number of groups and what the angle would be for these. And so, for example, if you have two groups, the furthest they can get, linear line, right? So we have two electron domains, electron groups around a central atom right here. And that makes a line, 180 degree separation. If we have three, that's going to make a trigonal planar, where it's a triangle in a plane, right? That's maximum separation, 120 degrees. Tetrahedral is 4 groups around a central atom. And so notice that looks like a camera stand. And why does that look like a camera stand? Because camera stands want to be maximum separation. So you can get the highest height, most stable base, right? Yeah. So tetrahedral, 109.5 degrees. Okay, let's talk a bit about the electron geometries versus molecular geometries. Our table has to get a little bit more complex. So right here, these are the electron geometries right here. And then what we're going to do is we're going to get into the molecular geometries over here, where we have these lone pairs. Okay. Okay. 2, that's linear, right? Okay. And that's really kind of the only option, because 2. If we have 3 here, so we have 3 groups, trigonal planar normally. If we're talking about in terms of our 3 groups being atoms, then that's going to be trigonal pyramidal right here. See, that has 4 electron groups, right? And that would be tetrahedral electron geometry. Okay? But in terms of molecular geometry, it's going to be trigonal pyramidal, because it's going to be a little pyramid with 3 different base sides, right? Okay. Can everybody see those okay? Tetrahedral here, we have 4 groups, right? And then we come up here, we have 2 of them that don't count for the molecular geometry, right? So lone pairs. And so what is that going to do? It's just going to leave this part, isn't it? And so that's bent for your molecular geometry. Okay, everybody check those out. We'll start up here next time. You all have a wonderful day. I will see you Thursday. Then we'll do some stuff Friday. It'll be fun. We'll get ready for the lab. We'll watch out on next week. Nope.
I didn't see anything on there. I just want to make sure.
Yeah, it's just come on in and we're going to talk about how everything works. And
I read over the lab thing you sent out that we're outside for.
oh, okay.
But I just didn't know if there was anything else we could do.
Oh, fantastic. See you in just a bit. Okay.
I just want to make sure I get counted.
Yep. Okay. Do you have your clicker? All right. And I'll just have you go ahead and answer.
Okay.
Just do your best.
Anything?
Yep. Anything.
I don't know what the question was.
Just answer.
Okay.
If you get lucky, you'll get it.
Okay. Whatever.
But either way, you'll get the attendance.
Perfect. Thank you.
No problem. Okay. See you Thursday. Okay.
I have to put my card.
Okay. Bring it on your assignments. So go on to Canvas, Assignments.